Hello, everyone. Mr. Minnick is my name. Math is my game. And on today in my advanced Algebra 2 class, we're talking about models. The title is Chapter 4, Section 3, Modeling Quadratic Functions. The interesting thing about the English language is one word can have several different meanings depending on the context. And in the context of mathematics, when we say modeling with respect to functions, we're not talking about Ashton Kutcher. We're not talking about Tyra Banks and how horrible of a hostess she is for America's Got Talent. I love Tyra Banks, but she does a lousy job on America's Got Talent. I'm sorry. I shouldn't have said that. Strike that from the record. Never mind. Anyway, Chapter 4, Section 3, Modeling Quadratic Functions. So basically what this means is here's our objective. Here's our goal by the end of this. The objective is to be able to write quadratic functions, given the vertex and a point, or maybe given the x-intercepts, I wonder if we could do that. I guess we'd have to know one other point. The x-intercepts and one other point and another point. I guess we would need one other point. And or given it already says given 3 points. If you recall from geometry, I know geometry was last year, but in geometry you learned that you needed 2 points to make a line. Well, parabolas, the slope changes, so you need to know at least one more additional point. So it's kind of interesting that what our objective is. So the objective is to be able to write quadratic functions given either the vertex and a point, the x-intercepts, and another point, or given 3 points. As you could probably guess, this is going to go from really easy to a little bit harder to, dude, really? And the dude, really, I've got good news at the end. You'll notice that I have my TI Inspire on the ready because we're going to use it and it's going to be making our lives a lot easier. Okay. All right. Any questions about anything before we see our first example? Okay. So keep in mind this lesson comes after we've seen these three forms. We've seen y equals ax squared plus bx plus c. What form is that called? That's standard. That's the one you don't want the abbreviation to. Then we got this one, y equals a times x minus h, the quantity squared, plus k. What form is that? That's vertex. And we've seen this other one, y equals a times x minus p times x minus q. And which one's that? Intercept or factored or intercept. So we're going to be using these three forms in one way, shape, or form during this lesson. So it's kind of handy to have those in your back pocket, so to speak. Some of you might know that in the past I was a mechanic. I still am. I love to work on things. And part of being a mechanic isn't, well, you have to know a little bit about electrical and mechanical engineering things and how parts work. But the big thing is having the right tool for the job. And in math, it's the same kind of thing. We need to know these three things. I would challenge you to memorize these, because on the chapter test, you're going to need to use these. So devote each one of those forms to memory, what each part of them tells you. Okay. So here we go. Example 1. Let's get right to it. Example 1. Suppose a quadratic function, that's my abbreviation for quadratic function. Suppose a quadratic function has vertex v at 3, -7, and passes through some point, we'll call it P, capital P, not to be confused with little p. Passes through some point P, which has the coordinates 4, 10. Write the equation of this function. I couldn't have been any nicer. This one's going to be super duper easy. Anybody recognize why right off the bat? Yeah. The point's one from the vertex, and what's that give me real quick? That tells me whether it's a stretch or a compression. It's going to give me my A value real quick, isn't it? If you really get what the A value is, you're thinking to yourself, dude, this is awesome. This guy couldn't have been any nicer to us. Our vertex is at 3, -7. Down here, there's our vertex, 3, -7. They say a picture's worth 1,000 words. In this case, a picture dang near answers the whole thing. Some other point P is at 410. 410 kind of reminds me of truck driving. 410, good buddy, or is it 10-4? I think I got it twisted. Anyway, it's 10-4. So what I like is I go over 1 and I go up 10. And if you understand what the A value tells you, then you'll understand that our A value in this case is 10, right? So we could put this in vertex form right now. We didn't even have to do any work. Our answer, y equals A, which is what? 10 times the quantity what? Times the quantity 17. Thank you. Why did I say 10? I should neck myself. Thank you. You got to keep me on my toes. It's Friday. It's payday. I'm excited to get out of here. So our A is 17. I'm sorry. Wow. Okay, so let's try that again. So y equals 17. Y equals 17 times the quantity x what? Minus 3 and quantity squared, and then what? And then -7. And then that's it. And then that's it. And then that's it. That was pretty easy. Question. The point's 410. My writing's kind of sloppy on that. I'm sorry. That's 410. Yeah. Sorry. My bad. Yeah, it's 410. So anytime the other point given is 1 next to the vertex, 1 over from the vertex, these are pretty easy, right? Well, let's try one a little bit more challenging, one where it's not like that. Example 2, suppose the vertex is 6, -4, and the point is 10, -1. So on one like this, we can still write 3/4 of our answer. Our answer is going to be y equals, I don't know what A is, that's what I need to find, times the quantity x something something squared. We should be able to fill in this, all right? What's going to go in the parentheses? X. Is it going to be +6 or -6? -6. Remember that right-left thing in the for the x-axis or x-coordinate of the vertex is the opposite of what you think. So x -6, the quantity squared, and then what? -4. All right. So we've written like most of the answer, and all we got to do is find the A value. Right? So when I go to find the A value, I like to think of Tom Berenger. Now, most of you are too young to know who Tom Berenger is. He's an actor who played in a movie a while back. Maybe you know Little Mrs. Fisher. Maybe you know Mrs. Rose. Maybe you know Mrs. Dempsey. Maybe they can help us. Those are all hints. Substitute. We're going to substitute. What's our tool we're using? Y equals A times x minus h, the quantity squared, plus k. The point P gives us an x and a y, doesn't it? The point P gives us our x and our y. So we'll say, okay, -1 equals A. I don't know what A is. I'm going to find it. Times x, which is 10, minus h, which is -6, quantity squared, plus k, so -4. So I've got to take that expression now, and I've got to simplify that. And I got to solve that for A, right? Don't forget PEMDAS when you do all this. Don't forget PEMDAS. You guys remember how PEMDAS works, right? So we get -1 equals 10 minus 6 is 4. 4 squared, 16. So -1 equals 16A minus 4. So I add 4 to both sides, so I'll get 3 equals 16A. So then I'll go ahead and divide. And so my A value is going to be what? 3/16. It's a weird A value. I don't like fractions, but that's okay. Fractions happen. Just get used to it. It's part of life. There it is. That's it. That's it. How do we feel about example 2? Not bad? Pretty easy? Cool. So going back to our objectives then, our first bullet point of our objective said you're going to be able to write an equation given the vertex and a point. I think we got a pretty good handle on that, huh? Well, let's look at the next thing then. 2 intercepts and a point. Given the 2 intercepts and a point. Example 3, write the equation of a quadratic function with roots at 8, 0 and -3, 0 that passes through the point 4, 97. I'm just making things up here. 4, 97. Just like we did before, we can write most of the answer without doing any work. We can write most of the answer without doing any work here, can't we? What's our tool that we're going to be reaching into our back pocket for? Y equals what? What form are we looking at here? A times x minus q, or the p and the q one, right? X minus p and x minus q, right? That's the one we're using. So our answer is going to be of that form. So our final answer is going to be y equals some a value, I don't know what that is, times x minus my p. Well, what's my p? 8's one of them, right? So x minus 8. And then what's my q? My q is the -3, so it's going to be minus 3. So what's that going to be in the other? X plus 3, right? X plus 3. We doing all right so far? So now, just like we did before, we got to call on the help of little Mrs. Fisher or Mrs. Rose or Miss Dempsey, and we're going to substitute, right? Here's our x, here's our y, here's our p, here's our q. So 97 would equal a, I don't know what a is, I'm solving for it, times x, 4, minus p, 8, times the quantity x, 4 again, minus q, so plus 3, right? So 97 equals a times -4 times 7. So 97 equals -28a. So my a value ends up being -97 over 28. -97 over 28. It's not very pretty, but that's what it is. So I just need to sneak that in here. -97 over 28. How are we doing so far with this, okay? Questions, comments, concerns, short or long debates? Cool beans. Well, that takes care of the second bullet point of the objective. And you're probably thinking to yourself, Self, we got like a half hour left. It's not going to take that long for the last one, is it? Yeah, it is. Math teachers like to show you the hardest way possible to do things, and then they try to be a nice guy or gal and say, oh, by the way, there's a much, much faster way. So here's our example 4. Example 4, write the equation of a quadratic function that passes through -1, -14, 1, 2, and 342. And 342. 3 is my favorite number. Some people argue that 42 is the meaning of life. It's not. Some people just say that. So what form could we use here? Are we going to use intercept form, vertex form, or standard form? Those are the only 3 tools we got. Standard form? Okay. So we're going to be working with this y equals A times, no, oh, it's ax squared plus bx plus c, right? So what do we know? We know x sub 1, y sub 1. We know x sub 2, y sub 2. And we know x sub 3, y sub 3. So maybe we could make some substitutions and get 3 different equations and have 3 variables and solve a system. Oh man. Sometimes we need to take our tools and modify them. I don't know if any of you have ever gone through a real mechanic's toolbox, but a real mechanic always has 2 or 3 wrenches that they had to make. The wrench that comes from Snap-on or Craftsman or Matco doesn't work the way they need it to. So they'll take a torch, they'll cut it, they'll weld it into a different position so that it works for their application. I'm going to do the same thing. I'm going to solve this, and I'm going to say ax squared plus bx plus c equals y. Okay? I hope that doesn't offend anybody, but I'm going to just put it in that form instead. So what I'm going to do is I'm going to take this first ordered pair, and I'm going to write an equation with that. So A, I don't know what A is. I do know what x is. What's my x in that one? -1. So A times -1 squared plus B, I don't know what B is. I got to find B. Plus B times, again, I know what x is. -1. Plus C, I don't know what C is. I'm going to be finding C. And all that equals my y value. So all that equals -14. Okay, I'm going to clean this up just because A times -1 squared, it's unconventional. -1 squared is 1, and A times 1 is just A, right? So I have A. B times -1 is minus B plus C equals -14. That's going to be one thing that I'm going to be using in a minute. So hopefully I can yep, cool. Well, all right, I'm going to come back and use that in a couple minutes. So we're going to have to do the same thing with the other 2 points, right? So let's see how that's going to go. So we'll have A times my x value. My x2 is what? 1. So A times 1 squared plus B times my x value of 1 plus C, and that's going to equal what this time? 2. So when I simplify that, that's going to be A plus B plus C equals 2. And I'm going to draw a box around that, and that's going to be another equation I'm going to use. Is this making sense so far, what I'm doing? I know it seems like a lot of work, and it is. You're going to be so grateful that we've got the Inspires today. Okay. The third time, then, hopefully by now you're getting the hang of this, we're going to go A times, whoop, that's supposed to be purple. Don't know why it didn't go purple. Let's try that again. A times 3 squared plus B times 3 plus C, and that's going to equal 42 this time. So I'll have 9A plus 3B plus C equals 42. Okay. So you probably remember from Algebra 1 solving 2 variable systems, or even from geometry. What we've got now is we've got this 3 variable system. A minus B plus C equals -14. A plus B plus C equals 2. And 9A plus 3B plus C equals 42. We've got that 3 variable system, and we need to solve it. There's this one technique called substitution, where you could solve one equation for one variable in terms of the other, substitute that into one of the other ones, and hopefully get it down to one variable, but that's not going to work so nice here. Remember the elimination or the linear combinations method? What I'm going to do here is I'm going to take two of these equations. I don't know which 2 just yet. Maybe the first one and the last one. Maybe the first one and the second one. I'd like to take 2 of them and add them together or subtract them so that when I do, it's going to wipe out one of the variables. If I take my first and second equation and I add them, that's going to wipe out my B variable, isn't it? That's freaking awesome. That's sweet. Let's do it. Let's do it. So if I take those 2 equations and add them, in other words, I take this blue one, Bueller, I take this blue one and add it to this red one, Cologne, and add it to this red one. That's going to give me something. That's going to give me something where the b's go away. The b's cancel, so I get 2a plus 2c is negative 12. You with me so far? Well, that's not bad. Now, I've got this equation right here, and this equation right here is in two variables. I can solve a two-variable system pretty easy. But I need another equation in two variables. So I got to go back to the drawing boards. I picked the first and the second. Now I can't pick the same two. I got to pick a different set. I could go with the second and the third or the first and the third. First and the third? Yeah, probably. But that I can't use just the first and the third because that's not going to get rid of anything. But I can triple the first one, can't I? So I'm going to have to triple the first one and then add it to the third one. Okay, so let's try that. So I'm going to go ahead and clone this, but I'm going to have to triple that. I'm going to have to triple that. And then I'll take this third one too then, right? All right, this third one is this. 9a plus 3b plus c equals 42. All right, so I'm going to take that one. But I got to triple this first one. I got to triple that first one. Oh, man. All right. So when I triple that first one, that's going to give me, I got to distribute all the way through, right? It's going to give me 3a minus 3b plus 3c equals negative 42. Then I'm going to get 9a plus 3b plus c equals 42, and I'm adding these two. Let's see what happens there. Oh, my b's went away again. That's awesome. I wanted my b's to go away again. I needed my b's to go away again. So I'm going to end up with 12a plus 4c equals 0. 12a plus 4c equals 0. Now we got it down to a two-variable system, right? So now we could take these two equations. Now we could take these two equations and maybe add them together and have one of those variables drop out. But we might have to modify one of the equations. What do you want to do? Yeah. So we want the coefficients to end up being the same, right? So we could multiply the first one by 6, or we could multiply the second one or the first one by 2. What do we want to do? The first one by 2? And we better go negative 2, right? Okay, so we're going to multiply this one by negative 2 then. So negative 2 times 2a plus 2c equals negative 12. We're going to do that and see what happens. We're good at the distributive property. Make sure you distribute all the way through here. So that's going to be negative 4a minus 4c equals 24 now. And then we could just kind of copy this other one, 12a plus 4c equals 0. So we got this one. Oh, man, really? Why didn't the whole thing go? There it is. Okay. So we'll go ahead and add those. And our c's go away. So we end up with 8a equals 24. 8a equals 24. So we could divide by 8, and we know then that a equals how much? A equals 3. So we're 1/3 of the way done. We got one of the three variables. Now we just need to go back and backfill. Anybody ever build a driveway? You know what backfilling's all about? So now we're going to go back and backfill. Maybe we want to use this equation here to find a, huh? Can we go back to that one to find a? Or we just found a. I mean, to find c. So we'll go back to that one. So 2 times 3 plus 2c is 12. So 6 plus 2c is 12. So 2c is 6, and c is going to be, is it negative? Thank you. Good looking out. Thank you so much. Appreciate that. That would have really messed things up. Oh, man. So that's going to be what, negative 18, and c is negative 9 then? All right. So c is negative 9. Thank you for saying something about that. Well, we got to go back and find our b. Maybe we'll go all the way back. Maybe we'll go all the way back to to this first equation here, this one, a plus b plus c equals 2. So a, 3, plus b plus c equals 2. So let's see, b minus 6 is 2. So it looks like b is 8 then, right? And I'm still not done. I found the variables. Now I got to write it. Now I got to write my answer. So my final answer, 3 weeks later, my answer is y equals a x squared plus bx plus c. Whew. Boy, I hope I don't have one of those on the Chapter 4 test question. I could have taken the equation a minus b plus c equals 14. Yep, equals negative 14. Yep. There's a lot more than one way to do this, by all means. Yeah, there's so many different routes you could have taken on this. So you had a different way to get B earlier on. Yeah. Yeah, you could do that. There's a lot of different ways you could do this, but the point is when you do this, you've got to have laser focus. You got to really bring your A game. You got to use the distributive property. And it's a fair amount of work, isn't it? Okay. There's a reason I had you grab the calculators. Do you all remember how to use a list and spreadsheets page? List and spreadsheets page on the calculator. That's what we're going to start with. We're going to start with the list and spreadsheets page. We're going to label columns A and B with X and Y. I'll write all the algorithm up and then we'll come back and fill it back in. So we're going to make a list and spreadsheets page. We're going to label columns A and B with an X and a Y. We're going to enter our X's in column A, Y's in column B, Y's in column B, and we're going to highlight columns A and B. So we'll have a list and spreadsheets page. Yeah. So we're highlighting a list, or we're going to make a list and spreadsheets page. We're going to label columns A and B with an X and a Y. We're going to enter our X's in column A and our Y's in column B. When we do this step, we got to make sure they correspond. Okay? Make sure they correspond. Corresponding. Make sure we get all that correspondence thing going. And then we're going to have to highlight the columns. I think probably the hardest part of all this is going to be highlighting the columns. Does anybody remember the little trick to that? When you go to highlight the columns, what you're going to do is you're going to arrow up and up and up. I know that seems redundant. I know it seems like I just said the same thing over and over again. I know it sounds like I repeated myself, but you'll see what I mean. You're going to arrow up and up and up, and then you're going to have to press shift, and you'll have to arrow either to the right or to the left. You'll see what that's all about in a minute. Okay. Like I said, we'll come back and do this actually in a minute on the calculator. After you've highlighted the columns, then what you're going to do is you're going to go menu, and after you press menu, you'll go statistics. And then you'll go stat calculations. Stat calculations. Menu, statistics, stat calculations. And you're going to choose option 6, quadratic regression. Quadratic regression. And then from there, you'll just follow the wizard, and it's going to output everything, and you'll just have to interpret your answer. It's pretty cool. I'll leave that up there another minute, and then we'll get right to it. We didn't do linear regressions in here yet, did we? Okay. I do apologize. There's going to be latency on my calculator when I go to do this. So, anybody need more time for the step-by-step? My handwriting's so sloppy you can't read it. Scroll up for how long? 4 seconds. You got it. 1001, 1002, 1003, 1004. This will be a PDF on Classroom too. So, yeah. All right. Okay, so here we go. We're at our calculator. Couple things about the calculator. I see people using the scratch pad. That's bad. Don't use the scratch pad. It's not going to do this stuff. Don't use the scratch pad. Anybody know how to start a new document? Where we go? We do like Dorothy from Wizard of Oz and click our heels together. We go home. There's no place like home. And then what? New document. Some people save their old documents, and every now and again I go in and clean them up. Some people put some really bad stuff in these things. But anyway, I don't want to save my old document, and the ghost of room 203 is moving that. I'm not touching anything. So anyway, I click no. And what did we say? What kind of page did we want to add right off the bat? Listen spreadsheets. You can either press number 4. You can use your fingers like a mouse on here. It doesn't work up here, but on yours, if you drag your fingers across it, it'll move the cursor. So you can move the cursor there. You can press number 4. You can click that however you want to do it. And there we go. Everybody make it there? Okay. If you don't get how to do any of this stuff, please ask questions, because when it comes to our next quiz, I'm not going to show you how to use the calculator again, so make sure. And we'll practice this again next week, I'm sure. All right, do you see where there's a tag next to the A and the B and the C? Doesn't that look just like a clothing label? Where do you think we're going to put our labels? In those cells up there, right? That's why they have those labels. So in those cells, we're going to put our X and our Y labels. Now, you don't have to do this. This is not an imperative step, but it does make things easier later on. If you don't do this now, later on, you're going to have to do more work. So it's pretty handy. So now when we go to enter things, I should probably tell you about this caveat. Do you guys know what the word caveat means? Spelled C-A-V-E-A-T. It's like, you know what it means? You'll have the most fun you ever have, and then there's an asterisk and a caveat that says, we don't necessarily guarantee this, but we're saying this. Yeah, it's kind of like that. Yeah, kind of like a warning. When I was a young lad, my dad always told me, don't put your finger in a light socket. And I said, well, what happened if you do? He said, don't do it. Being the curious young lad that I was, guess what I did? I unscrewed a light bulb, and I stuck my finger in a light socket. And nothing happened. And then I turned the switch on, and then I stuck my finger in the socket. And it shocked me really bad, and it hurt. And I didn't believe it, so I did it again. I was stubborn. Anyway, somebody's going to try it. I know there's like 4 people are going to try it. Do you see the equal sign, the box next to the equal sign? That box is capable of doing really cool stuff. If you understand sequences and series and the way the calculator likes data entered, you can have the calculator generate a list of random integers, or 1, 2, 3, 4, 5, or 6, 8, 10, 12, 14. You can have it generate those if you know how that works. Otherwise, the calculator might inadvertently generate a series of hyphens all the way down to infinity. Here's the problem. If there's hyphens all the way down to infinity, you're not going to be able to run this quadratic regression, and you'll have to delete each one. You know how long that's going to take? It's going to take a while. So anyway, let's not put anything in the box next to the equal sign until we figure that out. So we'll start with column A, cell 1. Let's put in our -1. And I'm just going to put all my X's in while I'm in column A. I'm going to put the 1 in, and then the 3. And everybody got those in column A, cells 1 through 3? Awesome. Moving over to column B, cells 1 through 3, we'll put our corresponding Y values. So we got the -14, we got the 2. I told you there was some latency. There it is. Bueller. Bueller. Negative 14. 2 and 42. Oh, 2 and 42. Okay. And 42. There we go. 3 weeks later. Okay. So, how do we highlight the columns? To highlight the columns, the procedure here says arrow up and up and up. I know it sounds redundant, but I'm going to arrow up. And I'm looking for the column to be highlighted. Well, I'm arrowed all the way to the top and it's not highlighted. Guess what I got to do? I got to arrow up again. And oh, now it's highlighted. Do you see why I said it 3 times now? Okay. So then I got to press Shift, S-H-I-F-T, Shift. When you press Shift, you'll probably see the Shift command show up on the calculator somewhere. And then press Over, and it'll highlight the other column. Shift and then Over. Were you able to highlight both columns? Okay. If you don't highlight both columns, it's not the end of the world, but it's going to be more work later on. So things that you don't have to do, you don't have to label A with X or B with Y, and you don't have to highlight these, but it's just going to be a lot more work later on. Okay. So now what did we press? What were the keystrokes? Menu, and then what? Stats. Some people use the D-pad. I like to press the numbers. Moving that D-pad around, sometimes the weird buttons get pressed. So I'm going to press 4, and then what? Stat calculations, I'll press 1, and then what do we want? Quadratic regression number 6. Quadratic regression. Now, do you see how it says X list is A, bracket, bracket? If you hadn't highlighted the list, that would not be populated. Do you see how it says Y list is from B, bracket, bracket? If you hadn't highlighted the list, none of those would have been up there. And you would have had to do it at this screen. Does that make sense? Okay. One thing that I always skip over when I do this lesson, and shame on me for doing it, what's going to happen is this equation is going to be saved as the function f1 of x. That's handy to know. Because later on, maybe we'll use this and we'll find additional points on this graph. If I press the tab button, I really like the tab button. If I press the tab button, it's going to cycle down through. It's going to say frequency list. It's 1, that's good. Category list, we don't need to worry about that. Include categories, we don't need to worry about that. Lastly, it tells me where it's going to put all the results. It's going to put it in column C. And that's okay. So we'll go ahead and click OK and see what happens. We'll click OK and see what happens. Do you see what shows up in cell D3 and D4 and D5? What do you think compared to what we just did for the last 15 minutes? You're welcome. Thank the TI Inspire. Oh man, that's going to be way easier. That's going to be way easier than doing. Let's see if we could steal. It's way easier than all that. Don't you just love how math teachers do? How they show you the hardest way possible and then they show you the easy way? Do you remember when we did this? This y equals x squared minus 6x plus 3, and you had to find the vertex? I'm going to quickly show you the fast way to do that, and we'll talk about this in 2 weeks' time. There's that. Maybe you get it, maybe you don't, maybe it just went. What kind of tomfoolery is that? Anybody see what happened there? If you don't worry about it. We'll spend all of chapter 4, section 7 talking about that. 2 days. Anyway, so let's try one more example. Let's try one more example, just to make sure that everybody has this. On my calculator, I'm going to write a function so that I can come up with some points on it, because I want something that's going to work out nice. So give me just 1 second. I should have had this found out before. All right, so the next example we're going to look at, boy, my calculator got all messed up. Somebody put it in scientific mode. Anybody else has given them the answers in scientific notation? I don't know why they do that. So the points I'm going to go with are going to be 1, -5, 1, -5, 2, -2, 2, -2, and 4, 10, and 4, 10. Here's the cool thing about this calculator. We did all that work. You could go back in, and you could update the x's and the y's right here, and it'll repopulate everything. You want to do that? Okay. So I'm going to just make this a 1, and this next one a 2. And it says singular matrix. Don't worry about that if you can advance through that. So I got a 1, I got a 2, and I got a 4. And then over here, I got a -5. I said a -5. And a -2. And a 10. Bueller. And a 10. Bueller. And a 10. I said a 10. Oh my gosh. You see why I don't like using this calculator in class now, right? And a 10. Oh my gosh. I said a 10. Oh my gosh. What's so hard about that 0? Really? Oh, and a 10. Okay. So that did it. That did it, huh? I don't have a -2. Are you serious? Oh my gosh, -2. There we go. Okay. I purposely chose this example because interpreting this one is something that some people don't do right. It's kind of like Spanish 3. Anybody ever take Spanish 3? Some people don't do it right. Spanish 3 is a tough class. Take it though, challenge yourself. It's a good class. So our answer is going to be y equals x squared, because my a value is 1, right? Okay. And on the end, I'm going to have a -6 because my c value is -6, right? Everybody with me so far? Okay. What's my b value? Yeah. -7/13? Nope. Good try, though. My b value is not -7/13. Yeah. -7^13. Good try, but no. Yeah. 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually, 12 zeros and then a 7. Yeah, it's that. Now, the calculator does its very best to approximate what the b value is. I'm Slim Shady. All you other Slim Shadys are just imitating. So won't the real Slim Shady please stand up and put one of those fingers on each hand up? What's the real b value? Sarah, I see you shaking your head. What do you think? Well, what's 0.0000000000000007 really close to? It should be negative, yeah. But what's that really close to? What number? It's 0. Our b value is 0. There is no b value. There it is. That's it. You got to watch out for that. A lot of people miss that. They see the 7 and they're like, oh, 7. No, it's not 7. It's 7 times 10 to the -13th power. The calculator did its best, and sometimes it's going to let you down. Sometimes it's not going to realize that the b value is actually 0. Does that make sense? I wanted to get doing a homework assignment. There's no way we're going to have time, so I want to look at one more thing. And it's going to show up on next week's exercises. What we'll do next week is we'll continue this next week. And I will have an exercise, and we'll have time in class to do that. We'll have time in class to do that, okay? But I do want to try one more example, and maybe this one we'll try from scratch. So we got 1, 8. So we got 1, 8. We got 4, 17. We got 4, 17. And we got -4, -7. -4, -7. So maybe we should go through this whole process from scratch, or maybe we could practice that again on Monday. So we got 1, 8, 1, 8, 4, 17, singular matrix. Okay, fine, singular matrix. I get it. I understand. 4, 17, 4, 17. Come on. Bueller, 417. For 17, not -17. And -4, -7. At -4, -7. So the directions might say, write a quadratic function that this models. What's my A value? My A value is not 2.2. Take a close look. Click on it. What's my A value? My A value is 2 times 10 to the -14th. What's my A value? 0. What do we say about the A value? The A value can't be 0. If it is 0, what kind of function do we have? We have a horizontal line. Could we, or not a horizontal line, I guess the A and B both would have to be 0. But do you see that this wouldn't be a parabola? This isn't a parabola. Our A value, if you look at the whole value, it's 2.2222 times 10 to the -14th. Our A value is really 0. So this information is, yes, it's a line, y equals 3x plus 5. There it is. It's the line, y equals 3x plus 5. It's impossible to write a quadratic model for that because it's not quadratic. So what I want you to watch out for is to make sure that you're actually clicking on those A's, B's, and C's and making sure that you read those numbers carefully. They're not always going to work out to integers. Next week's exercises, they might work out nice, most of them, but not always. I hope this has been educational. It's been real. It's been fun. Anybody want to give a shout out to anybody? Anybody who watches this back at home on Facebook, shout out to you. Shout out to the future Mr. Minnick for being such a nice guy. Have a great weekend.